Warning, I actually have no idea what I'm talking about, but I kind of have to put this concept down in my own head because I'm trying to understand what quantum is. So if you're out there and you do understand quantum, please let me know how far off I am with this following explanation. Time is an illusion, and there's a lot of philosophers have said this, and I think they've got it right. What's happening here is we have this illusion of time in ourselves, in our minds, because we write things down in our minds. So we get this illusion of a past. When we go back and we look at the past, we're either looking at our memory, which is a way of writing things down, so to speak, and we look at evidence that might be footprints in the sand or footprints in the rock that was once mud. And these are remnants, these are artifacts, fossils of what's left in history, this evidence. Well, as I want you to understand something, in order for what I'm about to explain to work, time can't exist. Time doesn't exist. Time is an illusion, and we think of time as, well, it extends into the past, so it must extend into the future too. I mean, that just makes sense. If it goes one way, it probably goes the other. Well, the thing is, it doesn't go either way. There is no future, there's only the now. And something a lot of people have been worried about the last, 100 and something years is quantum. And you get that whole cat analogy thing where it is both alive and dead at the same time in the box, and is the poison going to kill the cat, or has the poison already killed the cat? And that's a really stupid way to try to explain quantum. So first of all, something I need to explain is what is this illusion we have of time? We have a constantly written memory, hopefully, if you're healthy. So every time I wave my hand across the screen, it looks like it's going from here to here to here to here to here, and all the points in between. And I guess it is. I'm not sure exactly how to measure it. But what's actually going on is it's here, and it's in motion. So if I'm going this way, it's here right now, and it's in motion. So if that's our now, then what happened before is only in our memory, and what's about to happen is only in prediction. It's only in what we think is going to happen, because something might stop me from there's any kind of thing. There's anticipation of it moving forward. There's anticipation of it stopping. So congratulations, that's quantum. Okay, we have the now. The past doesn't exist, and as we have an anticipation of it stopping, that's one possible future. We have the anticipation of it moving forward smoothly. That's another anticipation of the future. And we have an anticipation of it stopping. The earth could stop. The sun could explode. I don't know. All kinds of things could happen. Those are all anticipations. But there's no such thing as future, because none of them are truly predictable. Okay, so that's what they mean when they say everything. That's what I mean. It's both in a state and not in a state until it's observed, until it actually happens and is put into place in memory. Our memories, and it were written down as soon as it's recorded somewhere in artifact. The footprints in the sand, the footprints in the stone that was once mud. That brings it towards reality. That's the anticipation being made solid. Now, let's go back to the time theory real quick. If you're running and you cover 10 meters in, 3 seconds, 2 seconds, or if you're walking slowly, 10 meters would be more than 4 seconds. Let's say 4 seconds for grins. And if you're running very fast, you cover 10 meters in 4 seconds, or you're walking very slowly, you cover 10 meters in 10 seconds. Where you're walking at a high rate of speed and covering 10 meters in 10 seconds, the difference is how much energy you're putting forward at any given point of time. See, that's the whole thing about you can't measure both the position and the direct and the velocity. You can't measure everything about. You can't measure position and energy at the same time. You can only measure one. Is the fact that you have the two devices. One's going faster than the other forward. So at this point, you see their position, but you don't know their energy, or you know their energy, but you don't really know their position I'm not sure how to explain that one with examples, because you have to measure the amount of energy something's using. We by the use of our memory and the amount of time that's going by in our heads, the amount of memory that we're writing down in between each slice of reality, or whatever you want to call it, the time, we are actually judging the amount of energy that's being consumed, not the time that's passing. The time that's passing, and the thing we call time, is sort of a misnomer that we sloppily use to measure the amount of energy. So all other things being equal, as two things go, one's going faster than the other, we would say this one's using the same amount of time to go further, therefore it's expending more energy. But the time is just an illusion in our head. So we're subconsciously measuring its energy as it's going in different positions. So we're using the position to determine its energy every single point along the way, usually the finish line, usually between the start and the finish line. And the memory, or the artifact that is the stopwatch, tells us how much energy went by. And it all boils down to quantum. Now imagine not being able to see what you're measuring, okay? Not being able to see the two things go by each other. Imagine all you have is an amount of energy that was consumed, because the total amount of energy in a closed system shrank or became more stable. You know, that's really what's happening. You have an X amount of energy, and all of a sudden you notice the energy becomes more stable. Less energy is being expressed, therefore some of it was consumed. Okay, so you're measuring the amount of energy, and then imagine you have a mass of particles. So you know that, well, some of the particles left, some more may have come in, but you get a mass, overall mass of whatever you're doing. So that's where the whole double measurement comes in, where you can measure the energy or the position of something. The concept of quantum can be applied to anything in the real world. All this goes out the window when you stub your toe on the way to the bathroom in the middle of the night. That's reality. Okay, then reality sets in that's all just a bunch of numbers and hooey. The whole concept of quantum doesn't mean anything when you just stub your toe on the foot of a dresser.